Hello all, this is Mr. G. In this video we're doing chapter 3 section 6, and after today we should be able to solve systems of three variables using matrices. Matrices. Now the singular of matrices is matrix, or rather I guess I said that backwards. The plural of matrix is matrices. So a matrix is essentially a table. I mean, that's sort of a basic way to think about it. So a matrix of numbers could look something like this. Maybe I'm just going to make these numbers up. 2, 5, -3, 0, 4, and I don't know, -1. Now, sometimes when we look at a collection of numbers, we're like, oh, what's the pattern, something like that. But with a matrix, with a table, it's just like, okay, here are some numbers. These are just some numbers we observed in this problem or that problem or this situation. And a matrix gives us a way to organize them. Now, doing operations on matrices is, well, let me put it this way. Addition and subtraction, they're not that hard. But when we're talking about matrix multiplication, it gets a little bit more confusing. But that's where our TI-84 graphing calculators come in, or really any graphing calculator. The graphing calculator helps us easily do operations with matrices as long as we know how to do it. And if we know how to do operations with matrices, then solving these three variable systems, what used to take us, 10, sometimes 15 minutes, we can get done just like that. Let's take a look at example 1. So example 1 says solve the system. We've got 2x minus y plus z equals -24, and x plus 3y minus z equals 45, and 4x plus y minus z equals 18. We're actually going to do this problem two different ways. I'm going to show you two different graphing calculator methods using matrices to solve this system. Now, the first way is actually my preferred method. I don't like the second method as much, but I'm going to show you both and you decide which one you want. So the first one is called using an inverse matrix. So what I'm going to do is essentially represent this system as in a sort of a matrix equation. So the first table, the first matrix is going to be 3 by 3, and we'll get to the graphing calculator and how we actually enter this in a second. The first matrix is just going to be the coefficients of the x's will be in the first column, y's will be in the second column, z's will be in the third column. So you can just keep track of what we're doing there. X's first, then y's, then z's. So first it would be 2, -1, +1, getting that from the first equation, just the coefficients, just the numbers in front of the variables, and remembering to be careful with our signs. For the second equation, it's 1 for 1x, 3 for 3y, -1 for -z. Then the last one is 4, 1, and -1. Just copying down the coefficients from our original three equations. Now, really, we're multiplying that by our x, y, and z. We're multiplying that by the three variables. Fix that so it actually looks like a z. That's a little bit better. That's still horrendous. Whatever. That's a z. Just take my word for it. And then that's going to equal our answers. So here, that matrix is going to be what we have on this side of the equal sign. The -24, 45, and 18. -24, 45, and 18. So what we've done here, we took our original system of three equations and rewrote it as, okay, one matrix, the coefficient matrix, times our variable matrix equals, the answers, not the solutions, but the answers, whatever we had right there at the end of our equations. Now this might look like kind of a nightmare at first, but once you get good at entering these in the calculator, you can run through these pretty quickly. So I'm trying to think, what's the best way to do this? Let's talk about how to enter this into the graphing calculator now. So let me turn my graphing calculator on. Hopefully you're doing this with me. Now the matrix button is right, let's see, there's second, then alpha, then math, then x to the -1. And above that, it says matrix. So I'm talking right next to the sign button. Above, I think that's the x squared button. It's kind of hard to see on the board. But I'm going to hit second and matrix. And that should bring us to a menu right here. We've got names, math, and edit. We're going to go to edit because we actually want to enter and change some of the matrices. We've got a whole bunch of options. I usually just use A and B. So matrix 1, this is, let me scroll down a little bit so we can keep track. So matrix A, we can still do this in blue, is going to be this first one. Right. The coefficient matrix. So that's a 3 by 3. 3 rows and 3 columns, or 3 columns and 3 rows. Either way, it doesn't make a difference. So then we've got our 3 rows. Then I hit 3 and enter, and it gives us 3 columns. Now I'm just going to type it in just as we have it written. So it's 2, Enter, -1, enter, 1, enter, brings me to the next row, 1, enter, 3, enter, -1, enter, and 4, enter, 1, enter, -1, enter. Always take a second to double check. So I'm going to double check my numbers. 2, -1, 1, 1, 3, -1, and 4, 1, -1. Okay, so far so good. We entered in matrix A, or rather we entered matrix A as our coefficient matrix. Now we're going to go back to the matrix, so second matrix. I'm going to go to edit. I'm going to go down to B. Now we're not going to enter the X, Y, and Z. We're going to leave that as it is, X, Y, and Z. But we are going to enter the matrix on the right as matrix B. So I'm going to edit this, edit, there we go. I went down to, yeah, it says matrix B, so I must have had B highlighted. And let's see, we don't want it to be a 1 by 1. I think a 3 by 1 will do it. 3, enter. Yeah, that gives us our 3 rows in just one column. I hit enter again, and then I type in -24, enter, 45, enter, and 18, enter. I'm going to double check that I have it typed in correctly, -24, 45, and 18. Okay, very good, very good. Now I'm going to hit second quit just to get back to a blank calculator screen. And before I talk about what to do next, let's just look at what we have here and think, okay, algebraically, how would we solve this? How would we get X, Y, and Z by itself? Now, essentially, okay, we're trying to get rid of this A matrix, that A table. And the operation we're trying to undo is multiplication. And a lot of students would say, oh, okay, I know how to undo multiplication. We just divide. So essentially, all we have to do is divide by matrix A on both sides, and that will cancel out matrix A on the right, on the left side, and we'll just be left with our X, Y, Z, our variable matrix, and then we'll be done. We'll have our variable by itself. It seems like that will work, but unfortunately, there is no way, there's not no way, but there's no operation for division when we're dealing with matrices. So what we need to do, we need to think of another way around this. So I'm going to give you a sample equation. Let's say we had that's a bad example. Let's make it 2/3. Let's say we had 2/3 x equals, I don't know, it doesn't matter, 5/6, whatever. To solve this equation, we could divide both sides by 2/3, because it is multiplication there. We could undo that with division, but I think an easier way to do it, since it's a fraction, let me do this in a different color, is to multiply both sides by the reciprocal. To multiply by the reciprocal, because if we multiply both sides by 3/2, the reciprocal of 2/3, then the 2's and the 3's will cancel out, and we'll just be left with x equals whatever the answer is. We don't care about that answer. What's important is we multiply by the reciprocal, and what's even more important is to remember that the reason we can multiply by the reciprocal is because the reciprocal is the multiplicative inverse of a fraction. So, like for example, 2/3 and 3/2 are multiplicative inverses. See that connection there? Inverse. Now, in order to know how to tell a graphing calculator to give us the inverse of a matrix, we need to know we need to know what sign it uses. And that sort of goes back to sine and arc sine, which hopefully you remember from geometry. Arc sine is the inverse of sine, but the way the calculator wrote it, they wrote it as sine to the -1. Now, this -1 is one of my least favorite things about a graphing calculator because it makes it look like it's sine raised to the -1 power. But this -1 right here means inverse. So that's the button we're going to be using to tell the graphing calculator, okay, we want the inverse of our matrix. So just keep that in mind as we go through our steps. So let's scroll back down here. So it's matrix A times our variable matrix equals matrix B. Well, we're trying to get our variable matrix, X, Y, and Z, isolated. We're trying to get the variable by itself. So we just said, okay, we know how to do that. We're going to multiply both sides by the inverse of A. Can I scroll this over a little bit? Yeah, that's a little better. So we can multiply both sides by the inverse of A. So our A matrix inverse, not to the -1, that's the inverse of matrix A. And if we do it on the other side, then we'll be good, because that will cancel out the matrix, and we'll be left with our variable matrix of X, Y, and Z, and we should be able to get our answer. So let's see how we can do that in a graphing calculator. So I'm going to hit on to turn it back on. Now, to get to our matrices, we have to go back to the matrix menu, so second matrix. And the way we have it written, it's matrix B times the inverse of matrix A. So I'm not going to go over to edit this time. I'm going to go right where it says names, and I'm going to go down. First we have B, go down to B and hit enter. Now I'm going to hit times, second matrix, A, already on A, and then I hit the inverse button, which conveniently is the same thing as the matrix button. We just don't hit second. And then we hit enter, and we get a error. We get a mismatch. Now this happens a lot, and this happens to me a lot if I haven't done these problems for a while, and I think, oh, right, I've got them in the wrong order. So if this ever happens, if you ever get a dimension mismatch, it just means, oh, switch them around. So we need to put the inverse of matrix A times matrix B, and that should give us the correct answer. So I'm going to hit quit because I don't care. I'm going to clear that out. Second matrix A, which is number 1. Then I hit the inverse button times second matrix B, which is 2. I hit enter, and there's our solution. So the variable matrix of x, y, z equals, what is it, -1, 12, and -10. That means that x equals -1, y equals, so x equals -1, y equals 12, and z equals -10. That's our solution. Those are the answers we get for our 3 variables. Now I know it looked like it took a while to do that, but I promise once you get good at this, you can run through it pretty quickly. All right. So that's one method. The second method we're going to go over is using reduced row echelon form. Now, using reduced row echelon form, I'm not as crazy about because this method at least makes sense to me. It's like, okay, so I've got matrix A times my variable equals matrix B. Okay, I use the inverse operation, so I multiply by the inverse. This method sort of makes sense to me. The reduced row echelon form, it basically just looks like, unless you really, really understand matrix operations, which some people do, which is great, it just sort of ends up looking like the calculator does magic and it just poof, you give your answers. But I will show you how to do this method, even though I myself am not crazy about it. So to do this, we want a 3x4 matrix. So I'm going to turn, instead of like one matrix equation, we're going to write it as, really what we're doing is we're taking the 2 matrices from the first method and writing them as 1. So the first line is going to be the coefficient, so 2, -1, 1, and then the answer to that first equation. So that first row of the matrix is really the coefficients, so 2, -1, +1, and then -24. Just the 3 coefficients and the answer. Then we just move on down the line. We do the next row is that one. So that's 1, +3, -1, 45. And the third row will be 4, 1, -1, and 18. So let's enter that into our graphing calculators. So I'm going to go to second matrix. Let's go to edit because I'm entering new values, and let's edit matrix A, and we want it to be a 3x4. So I'm going to change this to a 3x4. Hit enter, and you can't really see there, but trust me, it added on another column off the screen. So now let's enter this in. 2, enter, -1, enter, 1, enter, -24. Enter brings us to the start of the next one. 1, 3, -1, 45, and 4, 1, -1, and 18. So I'm just double checking, -24, 4, 18, enter. Let's go to the left just to double check those as well. 2, 1, 4, -1, 3, 1, 1, -1, -1. Okay, good. So we got this all set up. Now what we're going to do, I'm going to hit second quit. I'm going to go to second matrix, and instead of going and getting our matrix right away, I'm going to go to math and scroll all the way down. It's almost the last one. So I guess I could have gone up and gotten there faster. There it is, RREF. So that stands for reduced row echelon form. I'm going to hit enter, and then we're going to just go back and hit second matrix, grab matrix A, hit enter, and there it is. That's our answer. Now I'm going to copy this down because I want to draw your attention to something. So it's 1, 0, 0, -1, 0, 1, 0, 12, and 0, 0, 1, -10. So that means the answers are right here. So x equals -1, y equals 12, and z equals -10, which is the same answer we got the first time we did it. Now this right here, the 1, 0, 0, 1, 0, 1, 0, and 0, 0, 1, you have to make sure you see that. This is another reason I'm not crazy about this method, because a lot of times students forget to check that you've got, the ones on a diagonal there and all those zeros in the correct spot. If you have anything else besides that in the first 3 by 3, the first 3 rows and 3 columns of your matrix, then something's gone wrong. Either you entered it incorrectly, or it's a situation where there's no unique solution, or there's like an error. Weird stuff can happen here, which is why I'm not crazy about this method. But if you're going to use this shortcut, you've got to make sure that you check, okay, do I have the ones and zeros all in the correct spot? The ones at a diagonal, I guess it's the other one, my camera's reversed. The ones at a diagonal going this way, and everything else is a zero before you get to your answers in the last column. So those are the 2 methods. We've got this one, which I prefer because I feel like it's a little bit more intuitive. I can think my way through it. And then we've got the second one, which is a little shorter, but I think is less intuitive. You really have to make sure you memorize the steps. Now, real quick, I want to do 2 more examples just to practice these. I'll do one with method 1, and example 3 I'll do with method 2, just to give you some experience seeing more of both of them. So example 2, let's use method 1. So it's going to be matrix A times our variables, x, y, z. Once you get good at this, you don't have to write all this down. I'm just showing my work, equals matrix B. So let's set this up. I'm going to go to second matrix. I'm going to go to edit. We'll edit A. We want this to be a 3 by 3 now, not 3 by 4, so I change that. And then we just enter our coefficients. So it's a +1, -1, 1. We'll hold off on the 8, only the coefficients when we do it this way. And it's 1, 1, 3, and 2, -1, 2. And let's see what that looks like. Let's make sure I got it all correctly. So going down the x's is 1, 1, 2, then -1, 1, -1, and 1, 3, 2. Looks good. Okay. Now I hit second matrix. I'm going to edit matrix B. Hit enter. We want this one to be a 3 by 1, so I just hit enter twice. Now I write the answer. So it's 8, -12. Did I say -12? It's +12. +12. That was weird. It's 8, 12, and 12. Let's double check that one more time. Okay, good. And now, second quit. Now we just do our inverse. So we need inverse operations to get the variable by itself. It's going to be the inverse of A times matrix B. And we just type that in. So second matrix, grab matrix A, hit the inverse button. Remember, that's not to the -1. Even though it looks like it, that means inverse. Then times second matrix B, hit enter, and there we go. We get our answer of -2, 4, and 6. That means x equals -2, y equals -4, and z is +6. There's our answer. Right, hopefully you see that once you get good at this, you can run through these a lot faster than when we had to do them by hand. Let's do one more. This one, whether you practice it on your own first or using the first or second method, I'm going to show you the second method here. And there is something important to cover here. This is not just a fluff example, because hopefully you see there's something different about this. This second equation has only has only 2 variables. It's missing an unknown. So some students think, well, wait a minute, how am I going to enter that into the matrix? Well, we'll get there. So let's use the reduced row echelon form. I feel like I always forget the name of it. What is it? Reduced row echelon form. Okay. Yeah, we're just using the shortcut here. So that means we need a 3 by 4. Now we're going to enter it all in. So it's going to be 1, -1, 1, and -3. And then we get to our issue. What's going to go right there? Because there is no x for the second equation. Well, if there is no x, it's just a 0. That's really the coefficients, because 0 times x makes the x disappear. Then we just keep going. 1 for the 1y, 2 for the 2z, -1. And then 3 for the x, 1 for the y, -4 in front of the z, and the 62. I'm just going to hit second matrix. Now we're going to edit. Nope, we want to edit A. We'll make it a 3 by 4. Hit enter. And then let's see. 1, -1, 1, -3. 0, 1, 2, -1, 3, 1, -4, 62. Let me make sure I did that correctly. We've got the -3, 1 is 62. Let's move left so I can see all of it. Let's check. So we got 1, 0, 3, -1, 1, -1, and 1, 2, -4. We're good to go. Second quit. Second matrix. We've got to get our reduced form. RREF, it's right there. It's faster if you just hit up instead of down. Then second matrix, grab matrix A, hit enter. And first things first, we got to check that we got those ones in the diagonal which we do, and the zeros, that's excellent, so that's giving us the answer. No errors or any, like no unique solution or anything like that. Just x equals 11, y equals 9, and z equals -5. That is our unique solution. That is the one set of three values that will work for this system. X equals 11, y equals 9, z equals -5. If we ever get like an error or like a system that, because how do I want to say this? When we have two variables, it's pretty simple. It's like, okay, either this is one solution, there's no solution, or there's infinitely many solutions. With three variables, it gets a little bit more complicated. So we just say there's a unique solution, which we found, or if we get an error or something like that, we just say there's no unique solution. I'm not going to get super in depth into like all the different possibilities. When there's some solutions or infinitely many, it gets a little bit more complicated with three variables. But that's it. Hopefully this made sense. Hopefully at least one of those methods works for you and you figured out which one is best, at least for your tastes, we'll say. But any questions, feel free to let me know. Enjoy the rest of your day.